Yes, here we go. This is another topic, the next video, which is basically related to the electric potential energy and electric potential. So, as I was talking about in my previous video, that when we have to discuss about electric potential and electric potential energy, that means that there is a charge or any object. Let's say here we have an example. That example is basically the example of the gravitational potential energy. If you have a mass and that mass is placed on a surface and its weight is acting downward, the force of gravity, then if you want to pull it up against the gravity through a distance delta d, then you have to apply some force. In the same way, if there is a charge and that charge is being attracted by another charge, negative charge, that is the force Fe, then you are going to apply a force F applied to drag that charge through a distance delta d. So that work is done in stored in that charge in the form of electric potential energy. So remember this thing, that the electric potential energy is of energy per unit of a charge, and that is what that is electrical potential. Yani, if I say that how much energy is being required to drag or to pull unit positive charge, that is equals to electric potential. So here the potential is equals to E by Q, which is electrical energy. EP is electrical potential energy divided by Q is the charge. So that shows that if you have the stronger field, then definitely a sort of greater force will be required for the charge. So that is why if I just link this equation in such a way that E is equals to F by Q, and from here F is equals to E times Q, and the work which is done here, that is stored in the form of electrical potential energy delta EP. So here we go. Let's say I have a worked example. What is the kinetic energy of the electron in part B of the previous word example? Yes, that is in my first video. Because you have calculated the speed of the electron, that was here. The speed of the electron was 1.26 into 10 to the power 8 meters per second. This was basically the continuation of this word example. But over part is this, the kinetic energy is 1 by 2 mv square. The mass of electron is given to you and you are given with the speed, so that is multiplied and you are getting that electric potential energy. So part B, what is the kinetic energy gained by the electron increased through a potential difference of 45 kilovolt? So now in this case you will modify that equation. How? That the gain in kinetic energy is equals to loss in electrical energy. Okay, that is equals to E in K, yani gain in kinetic energy is equals to loss in electrical potential energy. So if I say that what is the electrical potential energy, that is V times Q. How did I reach this point? As you know that the potential difference was equals to work done per unit charge or energy per unit charge. From here the electrical potential energy, that is equals to Q times V. So you must know these 2 points. So here I will place that. Okay, so that is your kinetic energy. So here we go. The kinetic energy is, the potential difference is 45 kilovolts, so 45000 into one charge of one single electron, that is 7.2 into 10 to the power minus 12 joules. So this is again very smart work, that 7.2 into 10 to the power minus 15 joule is actually the amount of kinetic energy which is obtained when an electron is moved through a potential difference of 45 kilovolts. Here we go. This is the concept of uniform electric field, right? So as I told you that if this plate is at plus 2000 volt and this plate is at negative 2000 volts, then there is a potential difference between these two plates, and that potential difference is actually causing an electric field that is from the positive plate, it is pointing from positive plate to the negative plate. Remember one more thing, that these field lines are always perpendicular to the surface. Okay, so here we go. This is a sort of a oscilloscope's internal structure, you can say. These two plates are separated by a potential difference of 2.5 exponent 4 volts, and they have the separation of 1.2 into 10 to the power minus 12 volt. So we can find out the electric field strength in terms of V and D. So here I will let you know one thing, that electric field strength is directly proportional to the potential difference. If you apply more volts, it means more and more and more charges are accumulating here, so that more energy will be stored, and that is inversely proportional to the distance or separation between the plates. So if we say this is another formula, that is E equals to V by D. So remember this formula. This formula will be linked together with another equation you have, that E is equals to Q times V. So in this way, we use these equations together to figure out different formats, or to figure out different type of questions. For example, here is another example, that an X-ray machine, which I have shown at the start of my lecture, that has a potential difference of 45,000 volts between the cathode and anode. The electrodes plates are 10 centimeter apart from each other. The electric field strength between the plates is to be calculated. So E equals to delta V by D, or V by D, and potential difference is applied. The value of D is in the meters. So you will say that the electric field strength is 4.5 exponent plus 5 volt per meter. It means that electric field strength can be equals to V by D, and the other way it is equals to F by Q. So simply speaking, V and Q will be multiplied together. So I can say that electric field can have these relations, that V by D is equals to F by Q. So from here I can find out either force or something like that. For example, if I'm not interested in the force, what will I do? I will just figure out the acceleration. Let's say here it is F is equals to ma. So potential difference divided by V equals to ma divided by Q. So from here you can find out the acceleration, that qv by m times d. So sometimes you have the charge to mass ratio, and by that one you can calculate this all acceleration. So here some tips are there for your learning tips for the electric field strength, that can be defined in two ways, this one and this one, from this slide. So hope that this slide is clear to you. Now here is a practice problem for you all, and that practice problem is that two charged parallel plates separated by a 5 exponent minus 4 meter have an electric field of 2.2 exponent 4 volts per meter between them. What is the potential difference between the plates? So here I go. I will just solve this first part here, and the second part definitely lower one. So here, if you know that electric field is equals to potential difference divided by charge, so potential difference is equals to E times D. So electric field strength is given to you 2.2 exponent 4, 2.2 exponent 4, just plug in the values, 2.2 exponent 4 into 5.0 exponent minus 4. So you will get the same number, that will be 1.11 volt. So this is the example's answer. Now for the same situation, I have another, a spark plug of the car have an electrodes whose faces can be considered to a parallel plates. Yeah, this is a practical question, right? And the plate separated by a gap of 0.5.0 10 to the power minus 3 millimeter. Actually, if you have seen the spark plug of your car, there is a, this is an ignition point, and here at this point, this is the spark, or this is the distance where we actually, this is sort of spark plug. I'm not quite sure about, my drawing is not that much good, but here this is the gap of 5 millimeter, right? So that gap is 5 millimeter. So I'm gonna say that this is actually the distance, that is 5 into 10 raised power minus 3 meter. And if the electric field between them is this much, this is your electric field, that is 3.00 into 10 raised power 6 volts. Then calculate the potential difference. Oh my god, again you have to calculate potential difference. So that potential difference is E times D, and that is actually sorry, I think here I made a mistake. This was your answer, and this is basically answer of part 1. Sorry, this is 112 volt, 11 volt. This is the answer. Now E is 3.00 into 10 raised power 6, and distance is 5.00 into 10 raised power minus 3. So you will get 1.50 into 10 raised power 4 volts. So this is basically a simple application of electric field strength, electric potential, and electric potential energy. Now hopefully this video will help you out. So I'm gonna explain next part in the next video. See you in my next video.